Okay, Hadoop ecosystem. Last time we have seen the main core component is HDFA, YARN, MapReduce, and also the data collection like scope and the flow. Today we are going to see especially used for data analytics like peak Hadoop ecosystem, live Spark and so forth. Peak and Hive, especially like SQL or structured query like scripting and query tools for data processing and simplifying the complexity of MapReduce program. Pig is used to analyze data in Hadoop. It provides high-level data processing language to perform numerous operations on the data. And the Pig is a special tool for querying data in Hadoop cluster. So in Pig you have Pig Latin and the Pig Latin compiler. Pig Latin is a language for scripting. And the language and the peak runtime for the execution environment or converting peak Latin code to executable codes. The compiler internally converts peak Latin into MapReduce. So it provides the platform building data flow for extract, transfer, and the load. That it gives you platform for building data flow for ETL. One line of peak Latin, approximately 100 lines of MapReduce job, or 10 lines of peak Latin script is around 200 lines of MapReduce job. Peak first load the data, then perform various functions like grouping, filtering, joining, sorting, and finally dumps the data on the screen or stories in HDFS. So we have this allow to write data manipulation script written in high-level language called Pig Latin, and interpreted language script are translated into MapReduce jobs, mainly targeted at joins and aggregations, as you see on the so this is widely used in the Hadoop world. Yahoo estimate almost 50% of their Hadoop workload on the 100,000 CPUs cluster is generated by Pig script. The other one is Hive. Hive is facilitates reading, writing, and managing large data set residing in the distributed storage using scale have query languages as a data warehousing component which analyze data sets in distributed environment using scale like interface. Hive also has command line and JDBC ODBC drivers. There is two major components. The query language of Hive is called Have query language, has two basic components, Have command line and JDBC or ODBC drivers. So this is developed at Facebook, used for majority of Facebook jobs. Relational database built on Hadoop, maintaining state schema. Scale like query language, Hive can call Hadoop streaming and scripting from Hive, support table partitioning, clustering, complex data types, some optimizations. So Hive is supports user-defined functions to accomplish specific needs. As you see on the graph, there are computer optimizer, execution, job tracker, name node, or working with HDFS. Apache Hive is high-level abstraction on top of MapReduce. Uses an SQL-like language called Hive query language generate MapReduce jobs that run on the Hadoop cluster. Originally developed by Facebook for data warehousing, now on open source Apache projects. The other Hadoop ecosystem is Spark. Spark is special real-time data analytics. It's a framework for real-time data analytics in distributed computing environments. Spark is an open source distributed computing engine for processing and analyzing huge volume of real-time data. It runs 100 times faster than MapReduce or faster than Hadoop for large-scale data processing by exploiting in-memory computations or providing memory computation of data. It executes in-memory computation to increase the speed of data processing over MapReduce, used to process and analyze real-time streaming data such as stock market and banking data. It's a real-time in-memory data processing framework in general, Spark is. So Spark is written and Scala was originally developed at the University of California, Berkeley. So the Spark contains cluster managers and work node tasks, and also Spark can cache and has their own memory. So this is the Spark. The next one is Hadoop ecosystem Mahout or machine learning or Spark machine learning tools for running scalable machine learning algorithms in distributed fashions. Mahout is used to create scalable and distributed machine learning algorithm. Provide an environment for creating machine learning applications, machine environment builds, and machine learning applications. It performs collaborative filtering, clustering, and classifications. Provide command line to invoke various algorithms as libraries that contain built algorithm for, and also it has predefined set of libraries which already contain different inbuilt algorithm for different use cases. So this is Hadoop ecosystem analytics. Okay, thank you. We will continue next on the management. Another Hadoop ecosystem is Hambari. Apache Hambari is a management and monitoring software for provisioning, managing, and monitoring Apache Hadoop cluster. Hambari is an open source tool responsible for keeping track of running applications and their status. Apache Hambari is specially manages, monitor, and provision of Hadoop clusters. Monitor health and status of the Hadoop clusters, and provide central management service to store, stop, and configure Hadoop service, or starting, stopping, and reconfiguring Hadoop services. It gives us step-by-step processing for installing Hadoop service, handle configuration of Hadoop services, Hambari web, Hambari servers, or here we have a database, and host server. These are how Apache Hambari used and management and monitoring, or the provision of managing and monitoring Apache Hadoop cluster. Thank you.